All right, let's kick things off with a little puzzle. I'm going to show you three, totally normal, everyday things. Here's the deal. You have to find the one hidden science that connects them all. Ready? Let's go. Here's your first clue. First up, that glorious morning ritual. Making a cup of coffee. You've got your whole beans, you grind them into a powder, and then you run hot water through them. Simple, right? Okay, got that one? Next, picture this. You're at the beach, building an epic sandcastle. You've got sand, you've got water, and somehow they just stick together to make your architectural masterpiece. That feels a world away from coffee, doesn't it? And for our third and final piece of the puzzle, just using a vacuum cleaner. A machine that spins air around like crazy to pull dust and dirt right off your floor. So we've got coffee, sandcastles, and vacuuming.
So, what in the world is the connection here? What's the invisible thread tying these all together? It's not just about, electricity or water. It's something way more fundamental. Something about the physical stuff itself. Any guesses popping into your head?
Well, the answer is a field of engineering you've probably never even heard of, but I promise you use it every single day. It's called mechanical process engineering.
So mechanical process engineering, or MPE for short, is all about changing materials using pure physical force. I want you to think less about complex chemical reactions and more about things like pushing, crushing, sorting, and mixing. That's the hidden science. That's what links grinding coffee beans, getting wet sand to stick together, and using a cyclone of air to separate dust. It's all about physical transformation.
Okay, so let's dig into that a little more. Because once you get the main idea behind MP, you're going to start seeing it absolutely everywhere. And to do that, we need to think small, like really small.
There's actually a much better name for this field. In a lot of places, MPE is simply called particle technology. And honestly, that name makes so much more sense, right? It's the science of powders and grains and dust and droplets, basically any tiny little bit of stuff. We're talking everything from nanoparticles you can't even see all the way up to gravel. If it's a particle, it's MPE's game. So, how do engineers actually think about this stuff? Well, they look at the world in terms of what they call multiphase systems. And it sounds complicated, but it's a really simple idea. You have your dispersed phase, that's just the particles themselves, the stuff. And then you have the continuous phase, that's whatever the stuff is floating around in, like air or water. So dust in the air, that's a multiphase system. Sand and water, yep, that too. See? You get it.
And what's so cool is how these really simple combos create all the things we see around us. You put a solid in a liquid, boom, you've got a suspension, like mud in a river. A liquid in another liquid, that's an emulsion, like milk. A solid in a gas gives you an aerosol, like smoke. And a gas in a liquid, well, that's how you get foam, like the head on a beer. It's all just particles hanging out in a medium.
Okay, so if an engineer in this field is basically a particle technologist, what's in their toolbox? It's not what you think. We're not talking wrenches and hammers here. Their tools are these fundamental processes called unit operations. Think of these as the basic action words of MPE. First, you've got size reduction, or comminution, if you want to sound fancy, which is just a cool word for crushing and grinding. Hey, that's our coffee beans. Then there's separation, sorting particles. That's our vacuum cleaner, using a cyclone to literally separate dust particles from the air. And of course, there's mixing, like when you blend different powders or get a solid to spread out evenly in a liquid. These three actions are the building blocks for designing almost any process that involves particles. And this is where it gets really mind-bending. Mechanical process engineering isn't just happening on one level. It operates on this incredible multi-scale stage, all the way from how single molecules bump into each other up to the design of a whole factory. To really get what I mean, let's just take one of those unit operations, crystallization, which is just making solid crystals form out of a liquid. And we're going to zoom in, level by level. Okay, so first, let's pull all the way back to the macro scale, the big picture. We're looking at a huge industrial reactor. It's a massive piece of machinery, and its only job is to create particles with the exact right size and shape for some product, like a pharmaceutical drug or a food ingredient. Now let's fly inside that giant tank, resuming into the physical process level. Here we can see the actual crystals starting to form wherever the liquid gets oversaturated,
basically so jam-packed with stuff that it literally can't hold anymore. An engineer's whole job is to control this environment perfectly.
And now for the final jump, all the way down to the micro level. We're now watching individual molecules find each other and lock into place. This is called nucleation. It's the birth of a brand new crystal. And seeing this whole picture, from a single molecule all the way up to the giant machine, that is the real challenge and the magic of MPE. The engineer has to master every single one of these scales at the same time.
So, who cares? Why does understanding this hidden science actually matter so much? Well, it's because particles are, quite literally, the foundation of modern industry. And figuring out how to manage them better has huge consequences for everything. Our economy, our planet, you name it.
50%. Just let that number hang in the air for a second. What is that? Well, get this. In the entire global cement industry, 50% of all the energy they use goes into one thing: crushing rocks. That's it. Just comminution. Half their power bill is just for making big particles smaller. That's why MPE is so unbelievably critical. If an engineer can make that one single process just a tiny bit more efficient, the savings in energy and money and the environmental impact are they're absolutely enormous.
So when you boil it all down, what do we find out? That this hidden science, MPE, is really just particle technology. It's the art of using physical force to boss around tiny bits of matter. It's all about seeing the world as stuff floating in a medium. It's about understanding that process on every scale, from a single molecule to an entire factory. And it's absolutely essential for everything from our morning coffee to the concrete in our buildings. And that really leaves us with a pretty powerful final thought. We are getting better and better at controlling matter, particle by tiny particle. Things like life-saving medicines, revolutionary new materials, it all comes down to this science. So the real question isn't just about what MPE is. It's about what we're going to do with it. As our mastery grows, what incredible things will we build next?